Alright, good morning. Today we'll start on the topic of magnetism, and there are a few parts to this, so let's begin. Alright, so for magnetism itself, what we have here is we would like to understand the first part, the properties of magnet. So magnetism is a term we use to describe the behavior of materials in a magnetic field. So if we recall, we have talked about gravitational field, we have talked about electric field, now we have talked about a magnetic field. So what does a magnetic field mean? It's basically a region around a magnet in which any magnetic material will experience a magnetic force. So if we bring this back to gravitational field means it is a region around a massive object where if you were to put a mass in that field itself, it will experience an attractive force called gravitational force. How about for electric field? Now in electric field itself, if you have a charge there, is the region around this charge in which any other charges being placed there will experience a electric force. It can be an attractive force, it can be a repulsive force. So similarly for magnetic field, it can be repulsive, it can be attractive also. Okay. So we mentioned the word magnetic material. So what is magnetic material? A magnetic material is a material that is able to be attracted to a magnet, or sometimes what we call as ferromagnetic material. Ferro comes from the word iron. So some examples of magnetic materials are such as steel, iron, cobalt, nickel. You need to know this four. Examples of non-magnetic materials will be copper, wood, plastic, brass, and even aluminium. These do not get attracted to magnet. Alright, permanent magnets are magnets that are able to retain its magnetism for a long time. They are usually made of alloys such as steel. Steel includes iron and carbon. And they are also aneco, which is aluminium, nickel, and cobalt. Okay, so these are the contents inside. As you can see, most of them either have iron or cobalt or even nickel inside. Other types of permanent magnets include ceramic magnets. They are made of ferrites, iron oxide, and the rare element called neodymium. Neodymium magnets are very strong and are used in hard disks, earphones, loudspeakers. Yes, your speakers use magnets inside. You can get these magnets, neodymium magnets, very cheaply from Taobao also. Okay. So what are the properties? All magnets have the following properties: north and south magnetic poles. So if you have a bar magnet looks like this here. Okay, they have a pole at two ends of the magnet. This is where magnetic effects are the strongest. So you look at the two poles, this is where the magnetic effects are the strongest. When it's suspended freely, in this case here, okay, the magnet will come to rest in the position that is north-south direction. That means if you hang a magnet and you place it anywhere in your house or wherever, it will face and move towards a north-south direction. The end pointing to the north is called the north-seeking pole. Okay, so when your needle points towards the north, this is called the north-seeking pole, and when the needle points to the south, the other end that is pointing to the south is called the south-seeking pole. All right. Okay, so how do they behave? Let's say if you bring another magnet along, so now there are two magnets. So when they are like poles and they are being brought together, the magnets will repel. When they are unlike poles and they brought together, the magnets will be attracted. Okay, so please be careful. Down here we are talking about poles, not charges, as compared to in your electricity. Okay, so like poles repel, unlike poles attract. Okay, so with that in mind, we are ready to identify magnets. And please take note that this is very important because we want to identify magnets and there are certain properties. So let's follow this flowchart. First, you bring a magnet close to a material that you want to test. So in this case, let's say you have material X, you bring the magnet close to it itself. Okay. Now, if this material is attract, what does it mean? Does it mean that it's a magnet? No. It just means that we have to continue testing. Now, what happens if this material is not attracted? If it's not attracted, in this case, automatically it is a non-magnetic material. So that's very clear cut. What happens if it attracts, as we mentioned? But if it attracts now, what we got to do is you need to bring the other pole of the magnet close to the material. So now we turn the magnet around and we place it near to the material. So we got to repeat this with the other pole of the magnet. Now, if it gets attracted, does it mean this is a magnet? Answer is no. Okay, it only means that it is an unmagnetized magnetic material. That means it is a material, a magnetic material that is just not magnetized yet. It is not a magnet. It is just a magnetic material. Take note, there's a difference, not a magnet yet. Why? It is only a magnet if the material is able to repel. So now you turn it around, this magnet, the other end now repels. So not only does it attract at one end, it repels at the other end. Only when there's repulsion will we be able to identify the material as a magnet. So let's summarize. Magnetic repulsion is only way to confirm that an object is a magnet. Otherwise, attraction only means that it is a magnetic material. All right. Okay, so we'll end off for this part here. Let's continue the next time round on induced magnetism.